We will continue exploring more interesting functions by now looking at the graph of f of x equals x cubed. As before, if we want to see the whole graph, let's start with just a few points. As we add more and more points to our graph, we get a better picture of what the entire thing looks like. And remember, we can find points by picking x values and evaluating the function f of x to find what the y value should be. For example, if x is 2, then f of 2 is 2 cubed, which is 2 times 2 times 2, which is 8. So 2, 8 is a point that we can include on our graph. And if x is 1, then f of 1 is 1 cubed, which is 1. So 1, 1 is a point that we can include on our graph. How about if x is negative 1? Well, then f of negative 1 is negative 1 cubed. Negative 1 times negative 1 is positive, and if we multiply by negative 1 one more time, we get negative 1. So negative 1 is also a point that we can include on our graph. We don't have too many points yet, so let's plot some more to get a better picture. If x is 0, then f of 0 is 0 cubed, which is 0 as well. So we get the point 0, 0. And if x is a half, then f of a half is 1 half cubed, which is 1 half times 1 half, a quarter, times 1 half again is an eighth. So we get the point 1 half, 1 eighth. And if we plot more points and more points, we start to see what the graph looks like. And now we have a picture of the graph of f of x equals x cubed. It's worth noticing that this graph is not symmetric like f of x equals x squared was, where if we reflected it across the y-axis, we got the same picture. But there is some symmetry here. We call this rotational symmetry, because if we rotate the picture around the origin, we get back the same picture that we had before.